Now you guys saw about how we add two vectors, correct? Now see, whenever addition comes, commutative and associative law comes into picture, right? Now for vectors also we use these two laws. Now in vectors, commutative law and associative law, both of the laws holds good for vector addition. Now we'll see how why it holds good. See, in parallelogram law, what we did, you had vector A and vector B, correct? See, vector A and vector B, R was the resultant, right? Now, R is equal to vector A plus vector B. Now, see, this is vector B and this is vector A. Basically, R is also equal to B plus A, correct? Because that's also the resultant. So, in this case, we just proved that vector A plus vector B is equal to vector B plus vector A. Correct? So, commutative law holds good for vector addition. Now comes associative law. See, when it comes to associative law, what was the associative law? See, vector A plus vector B plus vector C is equal to vector A plus vector B plus vector C. Correct? This is what associative law. Now, same thing we can use, right? Same thing. So, you have vector A and vector B. See, vector A and vector B. Now, let's say the resultant, let's say we'll call it as vector C. Okay, vector C is basically A plus B. Okay, now from C, I'll take one more vector. Okay, from C, I'll take one more vector. Now, don't you think this is a polygon? Correct? See, polygon, n-sided figure. So, now we can say that even this polygon law for vector addition we can use, because see, triangle we used, parallelogram we used, now we are going on to polygon. Correct? Using this polygon, it will be very easy for us to use to prove associative law. See this here, you have vector A, vector B, vector C. Okay, now this will be A plus B plus C. Correct? A plus B plus C. Now what we'll be using, we are basically trying to prove associative law. Correct? Now we do A plus B plus C. What do you get? You get A plus B plus C. Correct? A plus B plus C. Now what we do? See, we do B plus C. Now if you do B plus C, now B plus C is, it goes like this. Correct? B plus C goes like this. Now when you add A to it, what do you get? You get A plus B plus C itself. So basically, associative law also holds good. Okay? So, two laws, and then you guys learned about polygon law. Right? See, polygon law states that any number of sides you have, see, vector A, vector B, vector C, vector D, vector E. Now, from O to E if you take, that basically gives you the sum of all the vectors, that is A plus B plus C plus D plus E. Okay? If you have n number of vectors, that's basically n number of sides for a polygon, that becomes the resultant of all the sum of the vectors. Okay? Now these are all the properties for addition. Now comes subtraction. Very easy for subtraction. See, you have vector A, okay, and then you have vector B. Now vector B, if you do minus B, it changes the direction. Correct? It changes the direction. See, your vector A, your vector B, and this becomes minus B. Right? Now use triangle law. You have A plus of minus B. Plus of minus B is what? Minus B. So you get the resultant as A minus B. So basically, whenever you have a negative vector, we change the direction, and we use the triangle law. Understood, right? So basically, subtraction of two vectors can also be done using the triangle law. So, remember these two laws, triangle law and parallelogram law, because the next video onwards you will be using this for further derivations in problems.